Very good evening to you, friends. Once again, welcome to Manthan, another episode of Manthan. In the previous episode of Manthan, we suggested an alternate model of universe to the contemporary classical model of universe. Classical model of universe is based on the existence of gravity. What we did in Manthan was that we exploited the intrinsic contradictions that were present in the classical model of universe, and we tried to uh, challenge the very existence of gravity. And we instead of gravity, we replaced it with spacity. And that model, we tried and showed it to all the contemporary models of the universe, starting from the solar system, the sun and the planets, the way they behave, and then the stars in the galaxy, how they behave, various types of galaxies. It was applied to and showed that it works well. It is not just the contemporary universe, but the early universe also. We applied the spacity model was applied and showed that all really worked well. And then we stretched it to the end of the universe, the possible end of the universe, how it could be. We used Carnot cycle to show that it could possibly be a cyclical universe. Among some of the episodes that we touched on in the Manthan alternate model of the universe was applying the spacity model to double slit experiment, and it was explained beautifully as to how the spectrum behaves the way it behaves. And another episode that we touched upon was the black holes. But our study was limited only to how the black holes are formed. What are the basic parameters of black hole? In the sense, the spin, the mass, these are the basic parameters of the black hole. But during this particular episode, what we are going to do is dig a bit more into the concept of black hole, in the sense how the mass behaves when it nears the black hole and when it crosses the event horizon and goes towards the core of the black hole. How does it behave? So let us start with this particular episode with a few questions. Uh, One may wonder, when the mass nears a black hole, it has infinite options to approach the black hole to reach the core. But we have seen that it takes a one particular path, which is equatorial plane, and it is perpendicular to the axis of rotation. And why does it do so? And we also see that the mass which is nearing the black hole, it is to begin with in the straight line, and then it starts bending, and then it is in circular concentric circles. So to understand this, it will be easier for us to understand if we study the black hole and the magnetic flux around it. You may wonder that magnetic flux is not available, is not existing near the black hole. So once we understand why the magnetic flux does not exist in a black hole, it will be easier for us to understand why a mass takes the path that it finally does. So what is a magnetic flux? Let us say in the case of Earth has a hot molten iron core which is spinning. This leads to the magnetic flux that is generally shown here around the Earth. And this magnetic flux, though in case of the Earth it is a decent strength, it is not something which is having a maximum effect. It has a decent effect, the way we encounter it in the atmosphere. Now compare it with a black hole. Black hole also has a hot spinning core, and it all started with an iron core. The collapse of the mass of the star into a core was basically when the fusion reached up to the stage of iron, and iron was it was not able to fuse any more elements beyond iron, and that is how it started. So what we have is when an Earth which has a molten iron core which is spinning can generate magnetic flux of decent strength, Why is it that black hole, which is many, many billions of solar masses, as heavy as that, and spinning at astronomical rotations, how is it that it has no magnetic flux or no effect? So we need to understand why. To understand this, the basic concept that defines the extent of magnetic flux is time dilation. What is a time dilation? Time dilation is basically that the clock ticks faster in the space than the clock which is on the ground. The difference is almost around 38 microseconds. You may say that it is very small in size, but if it is unaccounted for, the GPS that we use ultimately, if you don't account for it, this particular time dilation, you will not reach your destination. So it is important, the time dilation. But what is time dilation? Time dilation is basically mass affects time also. Generally, it is just said that mass affects the space. It is not just the space, but the mass affects time also. So if you have a massive mass, the effect on the time is also massive. So since the black hole is a massive mass, it will affect the time massively. Let me explain to you what I mean by massive effect. Let us assume the vortex that is shown here is the black hole. Now, let us assume for hypothetical reasons that we have a machine which can put two masses, two bodies in different space, in different positions of space, which are, let's say, billions of kilometers away simultaneously. So let us assume there are two twins born just now, and we use this machine and we put one of the babies near the black hole, in the vicinity of the black hole, and the other baby far, far away, a billion kilometer away, let's say, from the black hole. And when you observe that by the time the child which is far away from the black hole, it would age faster to the extent that by the time it has become an old man, the twin which is near the black hole would still be a baby. So that is how the time is getting affected. In the sense, the closer you are to the black hole, the time slows down to the extent that when you reach near the core, the time almost stops. Now try and imagine what is happening here. What are the various regions of the black hole? Right from, let's say, near the black hole to the accretion disk, the event horizon, and then the void, and then the core. So what we are doing is we are moving radially towards the core. So the distance is decreasing, and hence the effect on time is also increasing. So what's happening is there are various time zones right from core till the beyond the event horizon and in the vicinity of uh, the black hole. Now, let us now see how a magnetic flux could exist in such a situation. We said that since Earth, which has a molten, rotating, spinning core, iron core, even black hole also should be able to generate. It generates the magnetic flux. But let us assume that this is that magnetic flux. It's a filament. So what we are trying to do is, this is that line that I have shown as magnetic flux. As you can see, this magnetic flux has to exist in many time zones. In the sense, this particular part of the section of the magnetic flux is in, let us say, near the core is T0, T1, T2, T3, T4. In the sense, this physical entity of magnetic flux is existing across the time zones. For it to exist, it will have to exist across the time zones, which is not possible because magnetic flux is a physical continuous structure. The nature of the magnetic flux is continuous in nature, whereas the space near the black hole is divided into time zones. And that is how magnetic flux cannot exist near the black hole. So this is what is going to help us understand why the mass, which is nearing the black hole, behaves the way it does. So let's go to the next slide.